Good morning to all. Myself, Dr. Vinoth Kumar, working as Assistant Professor in the Department of Mechanical Engineering at Welltech Multitech, Dr. Rangarajan, Dr. Sagundala Engineering College. Now we discuss about the manufacturing technology. So this is the center lathe. Basically, the lathe is the oldest machine tool invented. It is the father of all machine tools. Its main function is to remove material from a workpiece to produce the required shape and size. This is accomplished by holding the workpiece securely and rigidly on the machine and then turning it against the cutting tool, which will remove material from the workpiece in the form of chips. It is used to machine cylindrical parts. Generally, single point cutting tool is used. Next, this is the headstock. So it holds the spindle, and through that the power and rotation are transmitted to the job at different speeds. Various work holding attachments such as three-jaw chuck, collets, and centers can be held in the spindle. The spindle is drive an electric motor through a system of belt drives and gear trains. Spindle rotational speed is controlled by varying the geometry of the drive train. Then the tailstock. The tailstock can be used to support the end of workpiece with a center to support longer blanks or to hold tools for drilling, reaming, threading, or cutting tapers. Also, it can be adjusted in the position along the waist to accommodate different length workpiece. The tailstock barrel can be fed along the axis of rotation with the tailstock handwheel. Next, bed. Headstock is fixed and tailstock is clamped on it. The tailstock has a provision to slide and facilitate operations at different locations. The bed is fixed on columns and carriage travels on it. Next, carriage. The carriage is supported on the lathe bed base and can move in a direction parallel to the lathe axis. The carriage is used for given various moments to the tool by hand and by power. It carries saddle, cross slide, compound rest, tool post, and apron. First, saddle. First, we know what is meant by saddle. So, saddle, it carries the cross slide. It carries the cross slide, compound rest. See, this is the compound rest and tool post. It is an H-shaped casting fitted over the bed. It moves along two guideways. Cross slide, it carries the compound rest and a tool post. It is mounted on the top of the saddle. It can be moved by hand or may be given power feed through apron mechanism. Next, the compound rest. For compound rest, it is mounted on cross slide, carries a circular base called swivel plate, which is during taper turning to set the tool of angular cuts. The upper part known as compound slide can be moved by means of hand wheel. Then the tool post. So it is fitted over the compound rest. The tool is clamped in it. Apron is the lower part of carriage is termed as the apron. It is the attached to the saddle and hangs in front of the bed. It contains gears, clutches, and levers for moving the carriage by a hand wheel or power feed. Next, feed mechanism. So the movement of the tool related to workpiece as feed. The lathe tool can be given three types of feed, namely longitudinal, cross and angular section. When the tool moves parallel to the axis of lathe, the movement is called longitudinal feed. This is achieved by moving the carriage. When the tool moves perpendicular to the axis of lathe, the movement is called cross feed. This is achieved by moving the cross slide. When the tool moves at an angle of axis of the lathe, the movement is called angular feed. This is achieved by moving the compound slide. After swiveling it an angle to the lathe axis. Next, feed rod. So the feed rod is a long shaft used to move the carriage or cross slide for turning, facing, boring and all other operations except thread cutting. Power is transmitted from the lathe spindle to the apron gears through the feed rod, namely a large number of gears. Next, lead screw. The lead screw is long threaded shaft used as a master screw and brought into operation only when threads have to cut. In all other times, the lead screw is disengaged from the gearbox and remains stationary. The rotation of the lead screw is used to transverse the tool along the work to produce screw. The half nut makes the carriage to engage or disengage the lead screw. Next, shaper machine. First, the shaper is a machine tool used primarily for producing a flat or plane surface which may be in horizontal or vertical or an angular plane, and it is making slots, grooves and keyways. So producing contour of concave, convex or a combination of this. And the its working principle is the job is rigidly fixed on the machine table. The single point, see, this is the table. The single point cutting tool held properly into the tool post. It is mounted on a reciprocating ram. See, this is the single point cutting tool. The reciprocating motion of the ram is obtained by a quick return motion mechanism as the ram reciprocates. As the ram reciprocates, see, this is the reciprocating movement. The tool cuts the material during its forward stroke. During return, there is no cutting action and this stroke is called idle stroke. The forward and return stroke constitute one operating cycle of the shaper. Then construction. The main parts of the shaper machine is base, body, pillar, frame, column, cross rail, ram and tool head. That is the tool post. See, this is the tool head and the tool post, tool slide, clamper box and block. So first, base. It is the main body of the machine. It consists all element of the machine. It works as pillar for other parts. Base is made by cast iron which can take all compressive loads. Then ram. So this is the ram. It is the main part of shaper machine. It holds the tool and provides the reciprocating motion to it. It is made by cast iron and move over ways on column. It is attached by rocker arm. So it is attached by rocker arm which provide its motion in crank driven machine, and if the machine is hydraulic driven it is attached by hydraulic housing. Then tool head. It is situated at the front of the ram. Its main function is to hold the cutting tool. The tool can be adjusted on it by some of clamps. Next, table. It is the metal body attached over the frame. Its main function is to hold the workpiece and vice over. It has two T-slots which use it to clamp vise and workpiece over it. Then clapper box. Or clapper box, it carries the tool holder. The main function of the clapper box is to provide clearance for the tool in return stroke, and it prevents the cutting edge dragging the workpiece while return stroke and prevent tool wear. Then column. The column is attached to the base. It provides the housing for the crank slider mechanism. The slideways are attached upper section of the column which provide path for ram motion. Then crossways. It consists of vertical and horizontal table slideways which allow the motion of the table. It is attached with some cross movement mechanism. Next, stroke adjuster. It is attached below the table. It is used to control the stroke length which further controls the ram movement. Then table supports. These are attached front side of the table and used to support the weight of the table during working. Then milling machine. In general, the milling machine is a cutting process that uses a milling cutter to remove the material from the surface of a workpiece. The milling cutter is a rotary cutting tool, often with multiple cutting tools, as opposed to drilling, where the tool is advanced along its rotation axis. The cutter in milling is usually moved perpendicular to its axis so that cutting occurs and circumference of the cutter. As the milling cutter enters the workpiece, the cutting edges of the tool repeatedly cut into exit from material, shaving off chips from the workpiece in each pass. The cutting action is shear deformation. Material is pushed off the workpiece is tiny clumps that hang together to greater or lesser extent, that is depending on the material, to form chips. This makes metal cutting somewhat different in its mechanics from slicing softer materials with a blade. The milling process removes the material, performing many separate small cuts. This is accomplished by using a cutter with many teeth, spinning the cutter at high speed, or advancing the material through the cutter slowly. Most often it is some combination of these three approaches. The speed and feeds used as varied to suit a combination of variables. The speed at which the piece advances through the cutter is called feed rate or just feed. It is most often measured at distance per time, that is the inches per minute or millimeters per minute, although the distance per revolution or per cutter tooth are also sometimes used. And some cutting parameters used in the milling. Spindle speed of revolution determines the velocity of cutting edge relative to the workpiece, namely cutting speed. Since the cutting speed has great effect on tool life, the selection of cutting speed relates to the durability of tool closely. Too low or too high cutting speed will cause the tool life to decline dramatically. Meanwhile, in the milling of thin-walled workpiece, spindle speed of revolution has a significant effect on the stability of cutting. Therefore, the spindle speed of revolution should be selected in milling process. Then cutting depth and cutting width are restricted by spindle power, the transmission power of machine tool, material type, tool parameters, coolant, machining procedure, and stiffness of machine tool workpiece system. And they have a great effect on tool life. Therefore, they should be selected reasonably according to the machining quality, machining efficiency, and machining procedure. Generally, machining efficiency is the first goal in roughing machine, so a larger cutting depth and cutting width should be selected. Quality of workpiece surface is the main goal in finishing machining. So a less cutting depth and cutting width should be selected. Next, feed rate. In feed rate is the velocity of feed move of the cutting tool relative to workpiece in milling process. Generally, linear feed rate is adopted in practical production and it is defined as feed per minute. The feed rate of milling will affect the machining accuracy, surface quality, deformation of the workpiece, and tool life directly. And it is also restricted by tool parameters, workpiece material, tool path, stiffness of machine tool, and performance of feed system. In machining process, the feed rate of milling is selected according to the part of the material, geometry features, quality requirements, and the capability of machine tool. Thank you.